There we go. All right, and we are live. All right, hey everybody, welcome to another episode of the Ruby Rogues podcast. I am your host today, Valentino Stoll, and I'm joined by a very special guest today.
Hey, I'm Evgeny.
Evgeny.
Yeah.
I'm so sorry.
Yeah, no worries. That's
Evgeny.
Yeah, even
yeah. Welcome. I appreciate you taking the time to come on today. Do you want to just introduce yourself and tell everybody why you've gotten so famous you're on the show today?
Not sure about famous, but I'm very happy to be here. And yes, I'm Evgeny, a long-time Ruby Rogues podcast listener. Thank you for inviting me. I'm a software developer, worked for many years using Ruby as my primary programming language, and created some open source libraries and gems like Batch Loader, for example. Recently, I started my own company called Bemi, and this company helps other companies track data changes in their databases. And I recently wrote a blog post about different audit trail approaches that can be used in Ruby. And yeah, today I'll be happy to discuss it and share my knowledge.
Awesome. Thank you so much. And yeah, I appreciate Batch Loader. I definitely use that every day. So very cool.
Nice.
Yeah, so I mean, audit logging is such a popular topic. To be honest, like one of those like kind of things that you over time will just end up using. Right? It's something that you want to just also drop in and kind of hope that it works, right? Like, and just like don't have to think about it again. I think for the most part. What kind of got you started down this path of like, really diving into this?
Yeah, it's funny that, you mentioned that everyone is familiar with this problem or maybe at some point heard about gems like paper trail and things like that. But I noticed that it's mostly in the Ruby community. When you step aside and, for example, go into like JavaScript world or Golang world, like people have not heard about tools like that. They would use completely different approaches. And because Ruby has Rails and Active Record as a like main ORM library, there are lots of unified tools. And how I first encountered, like first of all, I used all these gems maybe for many years. For example, Paper Trail is one of the most famous ones. What it does, it basically at a high level just connects to like your model. In your model, you have some callbacks, and these callbacks record changes in a separate table. And recently, I worked at a company called AngelList Venture, and AngelList used Ruby. And one of the main problems that I tried to solve there was related to tracking. And there are many different reasons why people would want to track their data changes. At this company specifically, it was related to compliance and regulation. So the company operated in the financial space. It was important. There are some certain compliance requirements, for example, SOC 1, SOX, and many different weird acronyms, similar to SOC 2, which is mostly about security, but those are related to like financial reporting and things like that. And it was super critical to be able to record what happens with data in the company, as well as be able to audit it and trace back like why this change was made. But I'm noticing that, full disclaimer, I'm working at a company called Bemi that we try to build a productized solution, something like that. And there are many different other reasons, like we're noticing why people care about audit trail in general. The most maybe straightforward one is rollbacks. Like maybe you like made some changes by accident or maybe by design, and you want to allow people to revert the changes they made recently. That's one of the use cases. Troubleshooting is another one. So there are lots of companies that want to understand what happened. Maybe some companies implement on-calls for their engineers, and they do something manually, go in and do something for their customers, and that needs to be tracked as well. Regulation, as I mentioned, in certain like financial sectors, banking and things like that. It's kind of like required. Some companies build activity feed as a security feature or table stakes features. For example, if you use like Notion, maybe enterprise plan would have like activity feed for admins to see what happens within the organization. And people can also use this data for fraud detection, analytics, and things like that.
Yeah, you make a couple great kind of crucial points here. Primarily, like there's activity, right? Like that people like to track, which I feel like often is like separated. And it's funny that you mentioned that this is like mostly like Rails and Ruby specific. And I think maybe the other realms like go toward like the log capture approach, where just like logs are getting blasted and you try and like resolve all of the timestamps as they come, which I think is crazy.
Yeah, there are many different like views on how to use, for example, data and interact with the database. In the Ruby community, like convention over configuration, we have active record and many other
Right.
ORMs, data mappers. For example, if you take a look at in the Go community, it comes from simplicity of the language. That is why many people try to stick with like low-level adapters and write SQL queries themselves. And that is why it's even like hard to build a unified solution like that. In the JS community, for example, there are lots of many ORMs that, I don't know, work on Edge and like work in serverless environments and things like that. So there are lots of crazy technologies, which is also hard to build a unified solution. But yeah, communities like Ruby, Python, I'm noticing that, yeah, they're more mature and they have already lots of great tools around that.
Yeah, that's really interesting. I mean, definitely we could take some learnings there. But I would like to just think about like, why people even like you mentioned a lot of like, mostly it seems like reporting and like trying to, align with, requirements, regulatory requirements or things like that, even internal, regulation where you want to be able to confirm that things are happening, why they changed, right? And I feel circling back to this like notion of like activity is happening on your app and you want to like be able to isolate how the activity affected your data. Is that kind of like the approach that you're taking with Bemi of trying to visualize how those two things match up, or where do you focus on?
Yeah, we take a slightly different approach. So there are many different approaches. So for example, I wrote this blog post article that describes some of the approaches. At a high level, I call them callback approaches. So paper trail, audited, Mongoid, history, and gems like that. What they do, they basically add callbacks. And when you use ORM, they would write a history of these changes in a separate table. There are some trigger-based approaches. So in a database, you can write code, which is dangerous, could be dangerous, especially if you're trying to implement complex business logic. But for simple triggers, it works. So you can try to implement triggers when, for example, a record is being updated, inserted, or deleted. Please do something. And there is one gem called Lagidze. It's very hard to pronounce when you see it, how it's spelled. But this gem, implements this approach with triggers. And I think that for majority of the companies, especially small ones, these approaches are great. There is like low overhead. You just add them, maybe add them even like just in case. Maybe you would do something dangerous and delete something by accident, or your logic was not tested well and it performed something crazy. And you would want to roll back. That's kind of like good insurance, I would say. At Bemi, we take slightly different approach. I can go more into details, but at a high level, we use replication logs as a solution. There is a pattern called change data capture, very weird like wording, but it's a data pattern used by data engineers very often. What it does, it basically capturing data changes from the database and moving these data somewhere. The most popular use case is probably ETL or solutions like that, when you would use some kind of like solution that connects to your database, for example, MySQL, Postgres, or whatever, and it tracks all changes and moves these changes to warehouse or something like that. So we use this similar approach, and change data capture, CDC in short, can be implemented in many different ways. There is like query-based, when you basically query by timestamp, for example, give me all records that were updated from the last like hour when we checked. It could be implemented by using triggers again, and at BEMI we use log-based solution. So Postgres, for example, has val, write-ahead log. MySQL has bin log. MongoDB, for example, it has uplog. Like SQLite has val as well, write-ahead log. So all these logs, I can briefly describe like why they exist in the world. So these write-ahead logs, they're designed to be able to quickly record changes in the database in append-only log before writing all the changes to the disk with data, indexes, and things like that that are heavier operations. And these logs, they are crucial for data recovery. For example, if your instance crashes, it would try to recover from the last state, replace certain, let's say, changes from the val, and get to the latest state. These replication logs can also be used for like cluster replication. For example, if you have like primary and secondary would connect to the write-ahead log or replication log in a primary and try to read it and get and sync the state. We use basically the same solution at BEMI. We are sort of connecting like a read replica, but we also decode it. It's called logical decoding. We decode all these changes so you can understand like it's not on a binary like file blob format. It comes from like decoded on a row level, and you receive all the changes, and we simply stream and store them as a kind of like, in a separate table, and people can use it and read it. And people sometimes, as I described, there are many different approaches or use cases why you would use it. But at a high level, what we do, we simply write a log of all changes that people want to track. They can specify like what table to subscribe to, and there are certain technologies on the Postgres level that were recently released that may help with performance as well. Plus, we have some nice UIs that people can use to see like what happened to this record and things like that.
This is really interesting. I love the article that you have that kind of breaks down all of this. I've never heard of change data capture before. It's kind of wild. There's a lot of pieces to the process here, which I think just comes honestly with a lot of the event-driven kind of architectures. So I just want to take a step back. Like, let's walk through kind of like, why would somebody, aside from like, let's say, like what are the primary use cases, I guess, for having for having a need for that level of like, orchestration and like granular rollbacks, right? Like what you're talking about is having like, I guess, a massive amount of data that you want to granularize what you're auditing and be able to recover from those in case anything should happen. Is that your primary focus, like focusing on that recovery when you're trying to do the audit trail, or like where do you see a lot of the, the most common use cases of having the audit trail, and where like just having paper trail like starts to fail?
Yeah, great question. We are noticing that it's a very horizontal solution and people use it for different purposes. That is why like it's great when you give a solution for developers and they build something on top of it. We have maybe three main use cases. One use case is just for troubleshooting purposes. We have, for example, there is one logistics company that has 30 or 40 customer support reps, and they're in the logistics business. So there's lots of real-time data from analog world, lots of unstructured data, and they leverage AI and things like that to help with it. But they need to see what's happening maybe help their customers and like cargo companies and things like that, help them understand what happened to this shipment, for example. And they have lots of different inputs. It could be like unstructured, just an email. It could be a doc signed or something that changed the status of the shipment. And they would need to troubleshoot and understand what's happening. So yeah, I previously, like as developers, one solution is just going to a Rails console or something like that. And if you use any of these solutions, you would just try to see, like, query a record and get all recent changes that happened to it when you need to understand, like, why is it in this weird state? Why it's not in like different state? What happened there? Like what API endpoint, for example, changed it and things like that, some additional metadata. The second use case is related to just, rollbacks. For example, we have, there is like one company related to carbon removal tech, for example, and they use PostGIS, which is like an extension for geolocation data on top of Postgres. So they do lots of changes in batches. And in certain cases, when there is an error or something, they want to roll back to the previous state. And it's possible to just track certain selected tables and work with any like extensions and things like that. And the third one is for many, it's like table stakes, whether it's because of regulation or, for example, there are in healthcare, it's very popular. There are like clinical trial management systems, for example. They need to track what happened to patients' data. And many of these solutions, like one fun story, at one company, we used Papertrail, and we had so many logs accumulated in the versions table that we ran out of integers. And we had to, like, the solution was simple. We basically, said, start recording all changes in versions v2 table. So we would keep the old one. It will be like called archival, but all new changes please record in a separate table because we don't have any integers there and for IDs. So that is why it's good to use UIDs when possible. But one issue with, for example, Papertrail and solutions like that is reliability. Maybe like maybe you heard that it's possible to, even with Rails, to execute certain queries that bypass the callbacks. For example, if you execute like delete all or update column or something, it won't trigger the callback. Thus, it won't record the history. So you will not have the complete history. So that is where like log-based solutions are critical and could be very useful, because even if someone goes directly to a database, executes an SQL query, it will be recorded because it happens on the like database level. And that's one of the kind of like main reasons in terms of, plus there are some additional benefits like no performance penalty. So you're in runtime, you don't insert any additional records. It happens asynchronously. But that's at a high level, yeah.
You made me think about because a lot of what we've been talking about has been surrounding like just auditing very specific processes around the data, right? Like we get a going back to the logistics approach, right? Like somebody submitted an order and they're tracking the process of that, and the order, I imagine has a table of orders and various aspects of the order that are being tracked with it, and that gets updated in the database kind of the same way, and it gets tracked, as it progresses through whatever business logic that we have. What I feel like is kind of missing from what we're talking about here is like that that overarching activity, like almost it makes me think of open telemetry, right? Where we have like distributed systems, right? Where they don't have to be necessarily, technologically, right? But they're distributed events that happen throughout the business that fire off, and some activity happens and that has effect on the database. What do we do for like cases like that? Like, are there like tools available to audit that process and how that's affecting the individual audit trails that are happening, and like how do you approach that aspect of it?
Yeah, you're definitely right. There are some like tools, for example, Datadog and things like that, that help with some visibility, observability, and tracing. Many of these tools, they either implement like just logging, so they would log what happens. And for example, if you use like Postgres, there is an extension, popular one called PG Audit. What it does, it basically logs all queries that were executed. So if for security reasons, someone, for example, gained access, you'll be able to, like during like cyber forensics operations or something, you'll be able to detect what happened and who executed what. So there are some solutions that do just logging of activity that happens, and you can do it manually as well. There are some gems like public activity or Ahoy gems that maybe used like Google Analytics on the front end or something like that, or in the browser. It's similar, but on the back end, when you can manually trigger certain events that you want to track, and they will be stored in structured format, not in logs, but in a database, for example. There are also solutions that help with just performance, observability, open tracing, and things like that. But there are not a lot of solutions that do something on a data level. And it's a little bit weird and funny because, yeah, most of the products, they use databases, and that's the source of all data. And yet we don't track it. Like developers use Git for tracking and versioning their code, but there is nothing for like databases. And to be fair, there are some solutions that people sometimes use. For example, there are maybe two technologies that may help you solve this problem. One is temporal tables, and another one is event sourcing pattern that some companies and people use. So temporal tables, I'll try to summarize it in the simple words. Basically, it's within the SQL standard since 2011. What this feature does, it basically, what I described, it kind of like has a version of all records. So you have your record, plus you have a range and a timestamp, basically a range of timestamps during which period this record was there. So for example, if you're updating a record 2 times, there will be 2 records in the temporal table. And the first record will have like an end time range when the second update happened, and second update will have like infinite time range starting with the time when this update happened. So with this functionality, and that's very powerful, it's usually helpful when you do, for example, reporting. I don't know, you need to generate some files or what happened last year, tax or something like that. That's very like powerful feature. Although many databases, including Postgres, unfortunately, don't have it implemented. So you would need to install some extensions or build it yourself. So that's one option. And another one for just auditing changes is rethinking how you make data changes is event sourcing. Event sourcing, in simple words, it's kind of like maybe the best analogy is Git. So when we use Git, we basically use an event source system. So Git records all events, commits, and all the changes that happened. And that's the source of truth. So commits become the main kind of like unit of data. And from these commits, the powerful feature is that you can travel in time. So for example, if you want to roll back or see what was the state of like 3 commits back, you can do that by traveling and basically undoing the changes of each commit. I would say from my perspective, like in software engineering, event sourcing is like a unicorn idea. Everyone is talking how cool that is, but very rarely people implement it or do it successfully, because it's a very challenging problem, because you deal with mostly with immutability of these events. So every change basically needs to be immutable. But what if you need to change the structure? Then you need to implement some kind of like versioning or replay the events and append some additional data or like change the things. Plus, then you would need to somehow get to the actual state. So you would record all events, for example, shopping cart. You would record an event that somebody added an item to a shopping cart, somebody clicked on purchase, somebody purchased, and it was paid or something like that. All these events would be recorded. But at the end of the day, you need to understand what was purchased, for example, when showing the whole like order history. To do that, people use projections, CQRS, like for like separating reads and writes, and lots of other patterns from the book called Domain-Driven Design, DDD. And that becomes very complex. I would say that event sourcing makes sense in certain regulated industries, and there are lots of great patterns or like how people do it. For example, double entry bookkeeping system in banks, or like accounting and things like that. This is standard where you would probably try to use this approach from the get-go.
Yeah, you make a good point. I mean, but all of my event-driven design, architecture-related stuff has always, the complexity raises as you start to spread things out and you try and like capture what, collect all of the things and merge, the state of things. Which pieces do you pick, right? Like anybody that's had a merge conflict in Git, can understand the issue here, right? Like, well, which changes do you choose, right? And that definitely becomes more of a problem as you start to spread things out with, your event-driven architecture.
Yeah, exactly. Yeah, it's much simpler to use, for example, like CRUD operations. For example,
right.
You just update the record and that's it.
Transactional, right?
Command, right?
Do it or not. Yeah. But it does make me kind of think like, okay, well, as it makes me wonder, like, I guess if you have a need for, right, like the things happening at different times, but really they're all the result of like one thing happening. Having a simple audit trail, like it makes sense to just throw a gem in and then just have it handle all of the things. But when it's something like, a time series database or something, like, are we just solving the wrong problem? Right? Like, why not just have something like in a time series database that keeps track of the data as it happens, versus spreading it out? Like, where do you see the benefit of having it be distributed like that, over having it be more transactional and having things like, okay, well, it happened in this series, like, is it worth it, what I'm saying, to have that distributed nature versus just like taking the time and doing things in series?
Yeah, that's a good question. And I think the best answer is, favorite developer's answer is, it all depends. But I think if you need strong guarantees and you have scale, then it totally makes sense to use this system. The question is then whether you buy or do it yourself. If you do it yourself, then you would need to start thinking about all these like technologies, cool technologies like Kafka, and maybe storing it in like, time series databases and columnar databases and things like that, or warehouses, and use it somehow. If you need to use it from the app, then you need to somehow connect to, I don't know, Snowflake to read it if you need it for like transactional or like operations, basically. I think like back to this like anecdote with large number of paper trail records, like anecdotally, like from talking to other companies, I saw that for many of them, just managing the database becomes much more expensive when you record everything in the same database. You would notice that like this versions table becomes the most biggest table in your entire database, and that affects everything. It affects like backups, the storage, how fast your database would run, how difficult it is to upgrade it at scale, how fast it will start, how like much traffic is there, plus activity and things like that. And at some that's probably like totally valid approach at certain scale, but at some point you would probably notice like, why am I storing it in my database that is being killed by this performance penalty? Because you're essentially doubling the throughput on every, for example, insert. You would insert an additional record. Or it could be even worse. If you're inserting 100 records in one query, it will be 1 to 100 plus extra 100 queries for each record that was inserted. It will be 100 additional SQL statements. And yeah, at some point, it makes sense to somehow extract these data. And it could be still in, I don't know, the same type of database that you use. And there are some benefits to it. For example, if your main transactional database is Postgres, for example, what we do, we store these changes and we call it destination database, where the changes are stored from the source database. We store it still in Postgres. The reason why is because one is easier to consume. You just use the same adapter, same ORM. For example, in Rails, you can specify a couple of connections. For example, for these models, go to this database, but for this model, go to the other database. So you on the application layer, if you want to consume those, you don't need to change anything. And two, especially in Postgres, there are lots of cool technologies that help you with scalability. One is maybe, time series we mentioned. There's like timescale extension or super extension, because it dramatically changes the way Postgres works. And it allows you to scale, compress data, and record events in chronological order that it is designed for that, with all these sharding, partitioning, and things like that.
Yeah, that's really interesting. That's definitely something I've seen. Scaling as things go, you want to set it and forget it, but then all of a sudden, you're like, well, why is the database crashing when we want to audit the audit trail and do any kind of reporting.
Yeah, and it affects not just database, even like your runtime, so your application is slower as the result because it waits for database, but also tests. For example, if you don't disable, for example, versioning for your models in tests, imagine like seeding a large like database or lots of things, testing things, it will just kill your test performance as well.
That's a great point. So I mean, what can we do to like avoid these pitfalls, right? Like aside from like you said, using some of these other extensions, like are there like best practices just like out of the gate that you can do to like maybe avoid some of the performance issues upfront without too much complexity?
Yeah, I think there is no like silver bullet, unfortunately. At smaller scale, for example, if you're a startup or something and you don't have lots of people or like customers or users, then it's probably not a problem, and you can just buy yourself time in terms of velocity by building features and not thinking about optimizing things. But as you scale, unfortunately, companies hit this kind of like moment when they realize they need something, and they already build usually like code base becomes giant. There are already lots of like team members and engineers on your team, and now you have to migrate everything, and that becomes very difficult to do if you want to like change things dramatically. And these migrations, I talked to some like people who build similar systems at, I don't know, Airbnb, Gusto, and other companies. It's all like very difficult when you need reliability, performance, and things like that. I would say, I think it depends on your business. If you're starting and you think you would need all these kind of like tracking functionality and it's business critical, it makes your business better. You can help. It can help you win customers and things like that, then I would think from day one, like how to potentially design this system. Either use like event sourcing or use these CDC, change data capture, or like some products that out there, something like that. But if it's just like secondary, then you can either buy at later stages if you're successful some solutions, or just it's not like a main problem, and it's probably will be deprioritized for many, many years.
Yeah, part of me always wished that there was like a log rotate version for database tables or things like that, right? Where okay, after so much time has passed, just take whatever's there and like stash it somewhere else. Almost like an auto database sharder. Right? Unfortunately, it doesn't exist, but
yeah, you need to build it yourself. Yeah, and we plan to do that. We call it like retention period. So how long people need to retain their data and changes and audit, because storing everything in the hot like database that can be queried at any time is expensive. That is why people sometimes move it to like some other cold storages and archival or something like that. Yeah, it's 3 buckets. And
that's awesome. I mean, it's definitely needed. I wish so many times I had just like an option to buy that, right?
yeah.
Rather than have to build it and manage it and worry about performance of everything. Yeah, for sure. So where are you taking this from here? Like, what are the next problems for you to solve? I mean, we've talked about quite a lot of different stuff. I mean, we haven't dove in quite to maybe some of the specifics, like doing various layers of logging, right? Like you've talked about like HTTP logging versus database specific auditing, right? And console logging, which we haven't talked about, but really interesting stuff from like 37 signals, right? With console 84 and audits for doing that in the Rails console.
Yeah, there are many layers. Yeah,
there's so many layers.
Many layers are covered, and some are just there are huge gaps. So, for example, you mentioned HTTP login, it's all done. For example, application execution, it's done. There are services, data, maybe it's solvable, and now we're trying to solve on the database level. Console access, it's also, I would say, a little bit specific to the Ruby community. For example, in the JavaScript community, there are not usually good like REPL consoles or that come with frameworks and things like that. And it's good and bad. I'm noticing that it's good that people don't go to this console to do crazy things there. Bad, sometimes they go to SQL console directly or connect to an SQL and perform changes on the database level. I don't know which one is better. With Ruby, it's luckily we have great like console experience. We have like gems like Pride that allow you to, I don't know, go and jump into like classes and inspect objects and things like that. And there are a couple of gems. One is console 1984 and another one Audit 1984. These are interesting gems. I personally haven't used them, but they seem to solve like very popular problem, especially among B2B companies probably. When you have customer data or customer request, you need to do something manually, but you want to audit what changes an engineer did, for example. What these gems do, they simply you install them in the Rails project. For example, when you load your Rails console, they'll prompt you and ask like, why are you here? Like, what do you want to do? And engineers can specify like a ticket number and specify some context. I'm solving this customer problem, blah, blah, blah. And you can type all the commands, and the commands may be logged in a separate database table. And the audits gem 1984 allows you to inspect all these things. You can implement some additional approvals or like retroactive approvals. But these solutions are like, and I don't know whether there is any better solution, but these solutions are not bulletproof in terms of reliability, accuracy, because it's Ruby. You can do whatever you want in a console. I can overwrite everything, and then after that, do crazy things that no one would see and notice. Of course, you're hoping that your colleagues or you won't do that, breaking all the rules, but it requires discipline. And it's funny, I tried to implement something similar once at another company when we had a little bit more complex setup with SSOs to AWS accounts. These accounts would run on Kubernetes certain process with the Rails console with some predefined end variables, and these kind of like sets certain context for example, paper trail or tools like that, so you can see who is making the changes. And yeah, I haven't shipped this feature, or it was not like released, but it's still, I would think that it's a problem for many. So if you're listening to this podcast, yeah, that's one opportunity to improve how to improve logging and auditing of their console sessions, because many companies just leave there, like developers leave there for troubleshooting purposes, yeah, and things like that.
Yep. Yeah, I remember first seeing console 1984 and the audits 1984. Kind of funny naming, but yeah, really cool. I've used them in a couple projects, and it does have like, you have to use like, what is it, that the active record encryption stuff natively. So if you use maybe Lockbox or something else, you're kind of like SOL.
Yeah.
But it's really interesting. Like the interface is definitely pretty smooth, and I do like it. But you're right, like it doesn't really prevent anything. It's more just like, all right, well, as long as and the goal is to hire people that you trust anyway. So as long as you have like at least a process in place to audit it, it definitely makes things much easier to track that.
And from your experience, what did you do in these consoles usually? Like, from my experience, it's usually either checking the data, what's there, because you don't have like full UI for everything or something like that, or sometimes editing some stuff there as well. So I'm curious whether it's a common way of using consoles.
I hate going in production console. So
yeah.
For me, it's mostly querying, if anything, right? Like you have a bunch of related objects, and it's like almost not impossible, but like much worse to like go into the a SQL dump or something like that and sift through the queries for it. But sometimes like you need to just update some timestamp somewhere. And it's just like, rather than having to generate a rake test that goes and runs, right? If you just have like one record that you're trying to get to, that's problematic. That's like, failing a ton of repetitive workers or something like that. And you just want to stop it from doing that, but you want to track that it's that you were the one that like updated it, right? And it's like very rare that you need to do that, but there are those cases.
In these cases when people need to update data, I think there are many also approaches how you do that. Like one-off, you can write a rake task. Some people run it in migrations. Some people execute stuff in a Rails console or things like that. I think there's also like opportunity to improve things, because writing, like, it's good when it goes through the code, but the cycle can be, and feedback cycle can be still like long, and you don't know like whether you wrote everything perfectly or not. You need to test it and things like that. And
I mean,
the changes.
I would say in general, like, probably don't update things in a production box in general, like no writing. I feel like that's a good rule of thumb.
Many just ban access, like only, for example, one person or like certain like DevOps team can access or something for troubleshooting or like certain emergencies.
I know some companies will do like, only the console access only gets read replicas, so then it just prevents it in general, right? So then you can only read from the database in general anyway if you're connected to the console, which is really interesting and definitely like prevents it, right? But definitely not as flexible.
Ideally you'd need to tightly isolate everything. Like there are certain other distributed systems like Redis cache, Memcache people can also use and drop things by accident. Ideally you would also want to isolate those, maybe certain HTTP requests, and we also like log in HTTP requests that are going from your application, because I can use all environment variables and send, I don't know, a Stripe API request to send myself like 1 million or something. Ideally, it should be also traced, like who made this HTTP request, or maybe ideally prevent it from doing it in a console.
So, I mean, you bring up a good point. Like, I feel like we haven't touched much on like the recovery aspect of all of this, right? Like, the whole point of audit logging is in case you need to recover something, right? Like, or you need, like, next to reporting, right? Like, so reporting, you can gather, okay, well, we're doing a, audit specifically of everything that changed this particular thing. But like, most of the times I feel like the reason for that is there's a recovery aspect following that up, right? Like,
Yep.
so where is that in this whole process? I know like some of these gems we've talked about have some of this, but I
Yep.
feel like it's still kind of missing. Like, what
Yeah.
is your like approach there, and like how are you working to like resolve this kind of like stuff?
Yeah, recovery is very tricky problem in general. One issue, for example, is what if you somehow backed up some data or certain rows, you have the record historical version, but now your schema has changed if you're using SQL or like databases. Like, how do you resolve this conflict? What if you added a column, you pre-populated it, but in your history you don't have it? Now you have to pre-populate it because the column may not like contain like shouldn't contain null values or something like that. So that becomes a problem. In general, yeah, gems like Papertrail, they allow you to query the version, find the right one. There is like a helper method called reify. You call it, and it basically instantiates an active record with the version, and then you can call save again, and it will overwrite and store the historical changes. As I mentioned, yeah, there are some schema changes. That's the kind of like up to people to decide how to resolve these conflicts. There are some other different approaches that on the database layer people solve. So the one is very straightforward. You snapshot or take backups daily, nightly. Ideally, you maybe test your disaster recovery procedures and test whether you indeed can recover, because very often no one tests those and just thinks that they're safe. And there are also new popular techniques. Maybe you heard about point-in-time recovery. So that's a popular feature that many database hosting providers advertise. What they do at a like in terms of implementation, how it works. Okay, how would you use it? You would use it by simply selecting any time you want to recover data, and it will either create a new database instance with the state as of this timestamp, or it will replace your database state. The way it works, it uses these write-ahead logs that I mentioned previously, because write-ahead logs are like append-only logs. These solutions, they continuously archive them. So some companies just take these vals and val records and they move them to S3. And then if you need to roll back, they give you like either the timestamp when, for example, a certain blob was archived, or they may also do some binary search within a certain file to find the exact timestamp you want to and try to recover to this data point. And there are some other like cool tag built on top of this idea. If you have like val and it's kind of like stored somewhere reliably, then you can do branching. So there are some lots of serverless hosting providers. What they allow you to do is to use basically copy on write copies for example, your branch when you want to test something on staging. What they allow you to do is basically create a database that will simply point to the state from a shared val kind of like log. So instead of copying all data again and paying for all extra resources, it will copy from the main, let's say, history, but any additional changes that you'll make, it will branch off and it will just incrementally record some additional stuff. So some super cool technologies that out there that help with branching as well as data recovery.
Yeah, I've definitely seen the branching. It's pretty interesting, like, because then it can just either wipe it off or like integrate it as it merges down if you want it to, which is pretty interesting. Like, but in reality though, like, what have you seen kind of like things evolve to? Like, what are people actually using? Are they using copyright? Like, it seems like a very like complicated process to integrate with. Like, where are the trends going?
Yeah, I think in general, people prefer cloud managed databases usually for these reasons, because they can manage backups reliably. So if you run something on RDS or like, I don't know, Render, Supabase, Heroku, whatever, you can trust that the backups they take, they're probably fine, and you'll be able to roll back if necessary. That's one first line of defense, is just relying on your hosting provider. And any additional ones, related to using additional tools. Like the way I think about what we do, for example, at BEMI, we provide selective point-in-time recovery. What it means, instead of like, it's very hard and dangerous to roll back the whole database state, rather than like rolling back certain data records that were affected. And with tools like that, when you can filter out changes and select the ones that you want and just apply those, that's very useful, because usually, I rarely saw when people would recover from like full database backup, because it means you would lose your history, what happened after that, if certain other clients used it and things like that. So it becomes very problematic and not very practical.
So I have to ask this, mostly because it's my interest, but like, do you see like AI fitting anywhere in this process, or is it kind of just like, there's this, it's too sensitive of a topic to integrate with?
Yeah, I think there are some, and I would share one idea that the problem we tried to solve with AI, maybe we'll solve it, but it's okay if you have desire to do it, go for it, because it will be great if you can solve it. But one maybe obvious solution is like AI for SQL. There are many non-technical people who want to use like inquiry data in a like business intelligence tool, Metabase or something else, but they don't have like the knowledge how to stitch things together for complex scenarios. That's one idea. Another idea is, we mentioned the audit trail and log. And for example, we have some customers, even non-technical people, use our UI for troubleshooting. But what could additionally help is data mapping. So usually database structure, it doesn't very well translate to real world language. You'd have some different IDs, maybe especially in Mongo. I remember like old days in Mongo, it's like document based like database, and it's doesn't have a structure. So the column names, you may have different columns, sort of columns. It was recommended for performance reasons to shorten your column names to like 1 or 2 letters or something like that, because it would take less space. And imagine seeing like an audit trail with weird like data changes, and with M is equal this timestamp, B is equals weird string. People would not be able to understand it. So where AI could feed it here is basically taking the structure and humanize it. Understand the data structure, understand maybe some business logic from the code base, and map it so anyone, even non-technical, like customer support, ops, like the CEO, could understand what's happening if they don't have like knowledge about how data is structured. And that's in general, related to these ubiquitous language, DDD concepts. Ideally, everything should be the same, but that rarely happens. That's one idea. Another one is like some companies, they maybe you heard about techniques like RAG for providing some additional context with custom data to your like AI system, so it can use internal data. Maybe you use Perplexity. Perplexity uses other resources that may be even like updated in real time just an hour ago. Plus, they have all these citation links pointing to the source. So RAG techniques can help you to do that. But companies in general, when they deal with internal data, Audit can also help. So you want to like have clean data, especially if you operate in the space when there are lots of documents, unstructured things, maybe files, maybe emails. So I'm not sure, like, it's for me, I don't know like how to productize it or what's the exact like solution. But the problem is that, yeah, people want to take this data, but they also want to understand like what happened, for example, why it was like that, why this AI system said it like that. Maybe we can fine tune it, and you'll see that with like, yeah, certain config changes, your response rate and accuracy has improved and things like that. So it's important to audit the results of the AI queries as well.
Yeah, super interesting takeaways there. Personally, I'm looking forward to it. Like, just getting some observation aspects of it out. So like kind of just automatically getting like the bullet gem or something like that just tells you, hey, like these things are not performing well, but without having to actually capture them. You can just look at it sideways, right?
Yeah, I hope, yeah, things will improve and things will be implemented. Yeah, I use GitHub Copilot, and yeah, it's, some people hate it, some people love it. I like it when it changes your mind. You have to know and understand how to use it as well to better leverage it. Sometimes I would write a comment explaining what I'm trying to do, and it would then suggest me some code that more or less matches, but then I would still need to check sometimes and things like that. But yeah, there are lots of opportunities for AI.
Very cool. Well, we've talked about so much here. Is there any other aspects you wanted to cover before we move into picks here?
No, I think we covered a lot of ground. I think in general, yeah, that's like tracking changes, auditing is a big problem. There are tons of ways how to solve this problem. Yeah, and I would recommend people try to evaluate them all instead of trying to just going with one by default because it's the hottest one or something like that. See what works best for you.
Yeah, well, for sure, people should check out Bemi, and your blog has a lot of great content around audit logging and tracking of various activities and database things you can add. I would definitely recommend people check that out for sure, because I'm already going to dive into quite a few articles on there. You got a lot of great stuff there. All right. Well, let's dive into picks. Do you have anything you want to share, or I can go first if you want some time to think about it?
I have two picks. One is non-technical and one is technical. So the non-technical one is, maybe if you're old enough, you remember there was a technology called RSS. And now I'm trying to use it on a day-to-day basis. The way I'm using it, so there are, for example, lots of great technical like channels or content out there, and instead of these systems being pushed to me or me checking, I don't know, subreddits or like Hacker News and things like that, I try to aggregate all my content as a kind of like funnel into an RSS feed. Some of them I use Feeder, but there are many others and they're similar. Some of them they have help you get email address, so you can also subscribe to Substack without polluting your inbox. So I'm just organizing it in different subfolders. I don't know, tech related, I don't know, some engineering related and other topics. And I aggregate everything like Substacks, top subreddits within a day or something with some URL arguments. You can get to these feeds as well. Tech blogs from different companies, top Hacker News within a day or something, digest. So lots of resources that can be accumulated there. And I have just a queue that I'm going through and reading when I have time on mobile or on the desktop. And my second technical pick is Nix. I'm not sure if people heard about this system, but it's basically a package manager and system configuration tool. It's sort of like RBAND, RVM, SDF, and all these things, but it's more powerful on the almost like operating system level. So it's not like just limited to programming languages, for example. But the way we use it, for example, we have lots of projects in different languages. There is a full disclaimer, Nix has, from my experience, has horrible DevX. It's very hard to use, very hard to understand what it does. So there are some wrappers around it, for example, DevBox, but there are many others. We use DevBox. So essentially what it allows you to do is to bring any tech stack without Docker to your local machine, and it's isolated to your project, meaning it will create a separate folder for your Postgres, for your Redis, whatever, for your like JavaScript engine or like Node.js or Ruby and things like that. You can specify all these dependencies. So when you go to your project, you can keep using your, I don't know, favorite ZSH or Fish or whatever shell, and it just automatically enables all these additional dependencies within this project. Yeah, these are my picks for today.
That's super cool. I'm gonna have to play around with that. Yeah, Nix is definitely a terrible user experience. So thank you for sharing DevBox, because that's pretty cool. So I only have one pick today. My awesome coworker Anna, she wrote this incredible article on the Doximity blog recently on evaluating GPT outputs and how we do it for medical professionals, and using golden data sets and programmatic evals and some human evals as well, to just make sure that the output you get from large language models is accurate, and at least following a certain set of standards. So I recommend checking that out. It's really awesome, and just like goes through a ton of stuff that we've been working on, which is really fun.
Yeah,
so
that's great. Yeah, I hope that all healthcare providers not just blindly use AI without evaluating.
I really hope so
out there.
too. Yeah, it's been great talking to you. I love to see all of the work that you're doing to help make auditing easier for a lot of businesses. And thank you for all the documentation and coming on the show today. It was really great. Chatting with you today. If people want to get in contact with you, how can they reach out to you or find you on the web?
Yes, I mostly and rarely use Twitter or X, how it's called nowadays. I have like Medium, GitHub, everywhere. My handle is ExaSpark. You can find me there. And yeah, thanks for having me here, Valentina, today. It was nice chatting with you.
Yeah, totally. Yeah, I mean, until next time, everybody, I hope you learned a lot and can make use of a lot of this stuff, because I know I will. All right. Bye now.
Bye.